Hello students, I am Dr. Saleha Jamal, Associate Professor from Department of Geography, Aligarh Muslim University, Aligarh. Welcome again to the lecture series on spatial analysis. As in previous lecture, we have discussed what is spatial analysis and its different types. During the different types, already we have discussed that there are 6 major different types of spatial analysis. Of that 6 major types, the first one was the query and reasoning in spatial analysis. Then there was measurement in spatial analysis, and then there was another, that is the transformation in spatial analysis. So in that lecture we have introduced all those types of spatial analysis a little bit, but now we are going to discuss it in detail one by one. So today's lecture is mainly based on query and reasoning in spatial analysis. So starting with the contents, the today's lecture will deal with what is a spatial query, with certain examples of a spatial query. Then we are going to discuss the different types of queries, that queries based on spatial relationships and attribute characteristics. Then we are going to discuss also the reasoning, because it is a part of query and reasoning in spatial analysis. So we are going to discuss the key aspects of reasoning in spatial analysis. Then we are going to discuss about the importance of queries and reasoning. And lastly, we are going to discuss the functions in spatial queries and reasoning and their application. So starting with the today's lecture, that is queries and reasoning in spatial analysis. Whenever we talk about the queries in reasoning in spatial analysis, uh, we have earlier also discussed that it is a very basic type of spatial analysis. Means it just answers the questions that is posed by the users, that analyst we can say. We are asking some basic questions and that is being answered with this application of queries and reasoning in spatial analysis. So overall, queries and reasoning is a category, is one of the type of spatial analysis that involves asking and answering question mostly about the spatial features and attribute. Why it is said that it is the asking about the spatial features and their attributes? Because uh, it is a type of spatial analysis, means related to the space. What I have said, when we talk about the spatial analysis, it means we are doing some work related to the spatial features, objects, their attributes. In simple language, we can say that related to the vector and the raster data. Whenever we talk about the vector data, that it is a spatial data pertaining to the location. It may be point location, linear location, that is line or area. And we may talk about the raster data, that is the attributes, that is the characteristics of those vector data. So queries and reasoning is that type of spatial analysis in which just we ask and answer the questions about different spatial features, entities and their characteristics. And it is one of the simplest one, it is regarded as one of the simplest one, because in this type of spatial analysis no new data is created and either no manipulations is data is done. It is just we are going to explore the different patterns and the trends that are present in the spatial data. Is there any sort of pattern, is there any sort of spatial relationship is present in that spatial data? That is to be understood. Then this queries and reasoning, generally it allows to use various geometry data, such like I have already discussed, points, lines, polygons. And these queries consider the spatial relationships between these geometries. What are the different spatial relationships are? And whenever we need to carry an advanced level of analysis, it is very important and necessary to use query and locate spatial objects. Why? In order to describe various distribution of phenomena, their variation, with simple measurements like length, area, distance, shape, you can see. So in advanced analysis, it becomes necessary to query and to locate the spatial objects and the entities. So it can be said that the spatial analysis begins with the spatial query. It is the first step of the spatial query. Without having any inquisitiveness, any question, any sort of measurement, we cannot proceed in spatial analysis. So this is a quantitative basis, we can say it is a quantitative basis of spatial analysis. So now, in specific and simply, if we have to define in very regular manner what the query and reasoning is in spatial analysis, then we can say it is sort of narrowed down question or tailored question which help the analyst to get a very meaningful insights and information from the maps and the spatial database to which we are dealing with. So there are various, here there are some examples with which you can make your understanding clear about what are the queries and reasoning. So queries and reasoning can be used to answer the questions. You can see the questions, the type of queries here. Which regions have a high population density? It is means region is related to the spatial aspect, and when we are talking about the population, it means it is the attribute of a particular region. So when the question is asked which region have a high population density, if it the question you can see here. So, if we are talking about the which region have a high population density, so to find this, we have to include, you can see, all the region, we have to select all the region having the population density greater than the certain threshold. If we suppose we are giving the threshold of 500 per square kilometer, then the regions having the population density of 500, above 500 per square kilometer may be included in the regions having high population density. So this is a simple query that is generally included in the spatial analysis. Another example you can see, how many schools are within the 5 kilometer a park, a sort of relationship. We are seeing the distance within the 5 kilometer of park. So in this, to find the schools within the 5 kilometer of park, we may select all the schools that fall within the 5 kilometer buffer around the park. Another example we can take, what is the average elevation of the terrain in a particular region? When we are querying this, what is the average elevation? What I have said, querying and reasoning is one of the simplest form of spatial analysis. It means we are not creating any new database, or even we are not manipulating or changing the database. What may be the average, it is fixed that what may be the average elevation of the trend, that is to be given. Another question, for example, we can take here which areas are at risk of flooding during the storm surge. We have to include all the areas which are vulnerable to different types of storm surge. Then another, you can see what is the distance between 2 points on a map. Points, I have already said that it queries about the certain spatial data with respect to the point, line, area data. If we are considering what is the distance between the 2 points on the map, the 2 points may be two different places also on the map. So these are the, we can say, queries and reasoning that could be used to answer these types of questions. So to answer all these type of questions and queries and reasoning, it includes selecting a subset. Subset means if we are dealing with the huge voluminous data sets, then we are selecting the data which we need, in which we are interested. That forms the subset of spatial features. So in answering these type of questions, generally selecting a subset of spatial features is based on their attributes and the spatial relationships with the other features. So these are the all different features which we have already seen. Now, query based on spatial relationships and attribute characteristics. After understanding, simply when we talk about the query are the simple question that is to be answered, that is posed by the users or the analysis. So there may be different types of queries. So here we are going to study about two major types, that is the query based on spatial relationships and attribute characteristics. So spatial relationship, it is total related to the space. We can say point data, line data, area data. Okay, fine, that is vector. And when we are talking about the attribute characteristics, it means the characteristics of that spatial entities, the characteristics of that spatial object, that is we can say the attribute. So mainly the classification is done on the basis of spatial relationship and attribute characteristics. So a query on, if we talk about the query on spatial relationship and attribute characteristic, it simply interrogates, asks the spatial data by considering both the spatial arrangement of the features, what I have talked about, the arrangement of point, area, line, the arrangement means arrangement of different spatial entities and their associated. We are just interrogating about the spatial arrangement of the features and their associated attributes. For example, if we take, suppose, spatial arrangement of the features. Here this is a school, we can say, and here this is a park, and here this is the residential colony. So we can say that we are integrating the spatial arrangement of the features. This is a school, spatial arrangement, this is park, and again this is the residential colony. Then associated attributes and relationship we have to assess in the query. For example, the school and park, residential colony, that's why the school is almost related near to the residential colony, and also park is related near to the schools plus the residential colony. It forms certain type of spatial relationships. So now that is spatial, that is query based on a spatial relationship, that would be more clear by taking the example. For example, if we are taking which buildings are within a certain distance from a river, just we locational aspect in terms of the distance we are taking, which buildings are within the certain distance from a river. It is a spatial relationships, means query based on spatial relationship. You can take another, even you can take another example, that is, you can take another example, what areas intersects with a given land parcel. What are the areas that intersect with the given land parcel? So here we are talking about the spatial relationship. Here we are not talking about the attribute characteristics. That the attribute characteristics means that is characteristics of a particular spatial unit, or we can say the spatial entity. So coming to the query based on attribute characteristic is a simply, we can say, the properties associated with geographic features. Yeah, properties, that is maybe population associated with particular region, income associated with the particular region, means income is a property of a particular region, population density is a property of is an attribute of a particular region. So attributes may include descriptive informations about the features like population, land use type, the temperature. These are all characteristics of a particular region. If we take the example, for example, what is the average population density in a specific region? Population density. This is population density. It becomes an attribute while a specific region is having the spatial relationship. So attribute query based on attribute characteristics. We are more interested in population density of a specific region. That's why it is a query based on spatial relationship. We can take another example, which areas have high concentration of particular land use type. For example, the areas having concentration in wheat cultivation. Okay, fine. So we have to find wheat cultivation. So wheat cultivation is the attribute of particular land use type. Simply we can take what is the average income of a specific region. Average income becomes the attribute of that specific income. So in simple terms, attribute means if we are interested in attribute query, it means we are very much interested in the characteristics of the particular region, that is the spatial aspect. So, these two are the major characteristics generally we deal in the spatial analysis. But there is another very important, we can say, very much important spatial characteristic, that is address matching query. We can say address matching query, and it is very different types of feature that is available in the GIS, that in which we enable the retrieval of spatial location and attribute details mainly based on the address. We retrieve the spatial, that is the location of the entities and all, and the attribute characteristic of that spatial feature in relation to the address. We are going to, it is specifically, it can be called as geocoding. If for example, that numbering the street, giving numbers to the streets, this helps very much in socio-economic surveys, in collecting data, in feeding data in GIS, and further it helps in, it has the various applications, like applications in postal services, the applications in communication, water and power supply, firefighting, medical services in any disaster and all. So another type of query we can have, the address matching query, that is mostly related to the geocoding. So but here only we are dealing with the two major types, that is the spatial query based on the spatial relationship and query based on the spatial characteristics. Now, after knowing what actually the query is and the basis of the queries, maybe on the spatial aspect, maybe on the attribute aspect, we are going to deal with the type of queries. What are the different types of queries? Already we know query based on the spatial relationship. This is one of the most important type of query. So here we will see various examples to understand what is query based on spatial relationships. That may be spatial relationships among the spatial entities, means we are talking about the spatial relationship. Spatial relationship means that is relationship between the spatial entities, spatial objects, that may be the topology, order, distance, orientation, etc. If we see the most important function in the GIS, that is, we can say, searching and locating the spatial objects. And this searching and locating of the spatial objects is mainly done through the spatial relations, which is different from the general database system. To understand this query based on spatial relationship, we can take example based on topology, based on the distance, orientation, etc. For example, if we take example here, first one, on the east of Beijing, on the east of Beijing, it means we are talking about the sequence orientation east of Beijing. You can say the state on the east of Madhya Pradesh. You can take it. Again, we are talking about the orientation, spatial sequence and orientation on the east of the states. On the south of Uttar Pradesh, we are talking about the sequence, that is orientation, on the east of Beijing. This is what spatial relationship. Another example we can take, no more than 50 kilometers from the Beijing. That is the Shanghai line, 50 kilometers. So in previous one we are talking with respect to the spatial aspect, that is orientation, and here if we are talking about no more than 50 kilometer, it means we are talking about the spatial distance. So distance aspect of spatial relationship is here taken. The relationship we have to include, we have to name the city. Now, when we are talking about this particular type of spatial analysis, that query and reasoning, we have previously talked about the query, and now we are going to discuss about the reasoning in spatial analysis. In general terms, what do you mean by reasoning? Simply, we can say a logical thinking, or some sort of, we can say, ideas which we are going to have with the logical thinking to get the better results or better information, we can say. That is the reasoning. Same reasoning can be applied in the spatial analysis, which includes the process of logical thinking. For what purpose? For getting the better result, better interpretations of different spatial patterns and relationships of various phenomena. And it may include various, while in this process of logical thinking and inference and all, it may include various analytical methods also. So reasoning includes various applications and the analytical technique also, in order to get deeper insights, more information, in order to have predictions of the future changes. It may also help to solve various problems and give evidence based decision making in various spatial context. So reasoning is also one of the is important type in the spatial analysis. So reasoning techniques can be used to get better, to have better decision, and it can be used in varied fields, like in urban planning, because in urban planning we need lots of measurements of the different aspect. Many times we have to reason out the underlying trends and pattern, which can work as a evidence based best planning methods. This reasoning can be also used in the environmental management, transportation, public health, natural resources, etc. Because many times reasoning uncovers the hidden patterns, the hidden trends, the hidden relationship, which may give a more deeper insights for the decision making. Now, what are the different aspects of reasoning? How it helps in spatial analysis? So, these reasoning can help in pattern recognition. As you can see here, the first point is the pattern recognition. It means we are identifying the patterns, the data to which we are dealing with, the spatial data to which we are dealing with. We visualize that data and reason out, is there any patterns are present in that, is there any trend is present in that particular spatial data we are dealing with, in which involves maybe recognition of certain clusters. That is, for example, the crime rate. The crime rate, why the crime rate? If it is a particular region, if particular spot, the clustering of crime is there as compared to the other region, we can see. So here we can say the clusters can be found. Similarly, if we see the concentrations, the distribution of various facilities and amenities, for example, the schools, we are talking about the clustering of schools can be found in this particular region, the distributional pattern, but this region is not having any school, although there is lots of population. So these type of visualization we go through during the reasoning while viewing the spatial data. Is there any anomalies are present in the spatial data which can provide valuable insight? So basically the pattern recognition is done with the help of reasoning in spatial analysis. Another thing, spatial relationships. When we talk about the spatial relationships between the geographical entities, between the spatial entity, is there any type of spatial relationship is there between? One example previously I have given, that there is a park. Why there is a park in this place? Because here is a school also, and these are the residential colonies. So the park is located here because of this reason. Why there is no park in this particular region? Because this is mostly the industrial area, and this is mostly the commercial area, we can say. So it analyzes the various relationship between the geographical entities, that may be in terms of the proximity, connectivity, adjacency, interactions, etc., we can say. Another key aspect of the reasoning in spatial analysis is the spatial correlation and causality. In this spatial correlation, we usually investigate different types of correlation and the causal relationship between the spatial entities. Is there any correlation is existing between the different spatial variables, or if we can see if one variable is changing, is it affecting the another variable? If one spatial variable relate to the changes in the spatial another spatial variable. For example, if the population of a particular region is increasing, then we can see the built up space, because if the population is increasing, the demand of the industrial area, commercial area, residential area will also increase. So pertaining to that, the built up space will also increase. So one variable is changing, it tends to change the another variable. For example, population is increasing, related to that built up area is also increasing. So reasoning also encounters and see the spatial correlation with its causes. Then it also models, है ना? Reasoning also see the spatial modeling and simulations. For example, developing different types of model and simulation. Why? In order to represent various phenomena and predict their behavior in different situations. For example, if any land use change is taking place, land cover is taking place at particular rate, then some spatial models may predict with the same rate, with the same trend, with the same behavior, what will be the land cover change after 20 years or after 30 years. These models may be of mathematical models, statistical model, computational model. For example, for reasoning out the future land cover, we can use ANN model, we can say neural network model, we can use the Markov chain model. So these also reasoning helps to spatial modeling and simulation. So another we can say geospatial reasoning. Another key aspect of reasoning is geospatial reasoning. That is somewhat we can see reasoning the techniques for the geographical aspect, for the spatial aspect. It includes reasoning which involves understanding and manipulating the spatial relationships, and temporal reasoning, we can say. Similarly, there are other also key aspects like multi-criteria decision analysis. We know we acquire the spatial data from the different sources. We have multiple data. We can overlay one data upon the other. We can intersect to get some deeper insights and the information. This is also used for the uncertainty and sensitivity analysis. So these are the major key aspect of reasoning, we can say. Now, once getting the in-depth understanding about the reasoning and query in spatial analysis, why it is important. Now, what is its importance? These queries and reason analysis facilitates the extraction of useful, deeper insights, useful information from the spatial data we are dealing with. For example, you can take the example, if we are having a map with lots of information of the different places, then spatial query usually narrows down. It works as a magnifying glass which help us to zoom one specific detail which we are in need, which is mainly needed by the analysis. So mainly in spatial data we deal with voluminous data. So queries and reasoning, their function is to narrow down and narrow down for this that data to create subset of that particular data to which we are interested in. For example, it is just, we can say that it is finding the one of the most important jigsaw puzzle. Instead of looking all the entire picture, we are just going to focus on the parts that matter to get clear understanding. So it facilitates in getting more deeper insights from the spatial data. It also enables the different decision makers, stakeholders, different professionals to make informed decisions by revealing various patterns and the trends. Just think of a certain detective who looks for the clues. Spatial queries help the professionals to uncover patterns and trends that might not obvious at first glance. So it generally uncovers the hidden pattern and trends. It also, we can say, you can take the example, it is evidence based. During the reasoning, during finding out the patterns and the trends, just like the detectives use to solve a case, queries also, spatial queries also help to gather information that may guide the decision makers and the planners for more informed and more smart decision. So it also helps in extracting the relevant subsets of data. Already we have talked about as we deal the voluminous data. So it extracts the subset. For example, if we are talking about to find out the regions, to locate the regions having the population density greater than a particular threshold, it means we are here forming the subset. We are going to include all those regions having the population density higher than a particular threshold. We are extracting, we are forming the subset. Not only the queries in spatial analysis helps in extracting, enabling and all, but it also helps in supporting and optimizing decision making and the resource allocation. In decision making, by revealing the hidden trends, patterns and different types of aspect, better decision can be taken. And by optimizing a particularly relevant scenario such as infrastructure planning, where the understanding the spatial patterns of demand, where the demand is there, we can have the resource allocation. That is the optimizing function of the spatial analysis. Finally, we can say the query and reasoning in spatial analysis. We have to answer the simple question that is posed by the users or the analyst, we can say. So to answer these questions and queries and reasoning, typically it includes selecting a subset of spatial features which is based either on the spatial relationships or which is based either on the attributes. For example, to find the regions with a high income, we might select all the regions with the income greater than a particular threshold. And to find the hospital within the, another example you can take, to find the hospital within 10 kilometer of residential colony, we might select all the hospitals that fall within a 10-kilometer buffer around the residential colony. So here we are forming a subset from the voluminous data. This is the major role of queries and reasoning in spatial analysis. Query just asking question, we can say simple question, and reasoning giving the logical thinking, revealing the hidden trends and patterns in the spatial data. So that's all for today's lecture in spatial, we can say the queries and reasoning. That is a particular type of, one of the major type of spatial analysis. We will continue with another type, that is measurement, in next lecture. Thank you, student. Thank you all.